Hello students and welcome back to Mechanical Engineering Practice and Graphics Lab. Today I will be covering the Chapter 7 Advanced Modeling Tools, and actually I'm just gonna do a tutorial today, and there will be a couple of announcements during this class. Now the first announcement, by checking the schedule, remember that this week we had scheduled the second quiz. Uh, if you don't know, we are allowing those students that had technical issues or needed more time to deliver the second quiz. Just send me an email on the reason why you needed to submit it late, along with the files of the quiz. Then I will verify if I should give you an extension or not. This week we have several activities, not only the quiz, but also we have to do a draft for the group project. I'm going to show an example of a draft that one of the groups already did, and I think it's a good example for everyone in the labs. And also there will be the fifth homework due this Sunday midnight. This is another reminder. Remember that I am requesting you to do a quick table of the members of your team with the contact information. Some of you have already provided this information to me, but not all of you. And I would like to see that you are organized and ready to tackle the group project. If you don't know what I'm talking about when I am saying the group project, please verify the slides and the video tutorial of the last week when I introduced the group project. Remember that we are also available in the GroupMe chat. Here is the link, and I am available to answer questions there. If I don't answer, most probably any other student will. So please try to join the group, since this is another fast communication channel between you and I. For the draft, this is what I'm requesting. It's just a quick sketch, something general of the vehicle that you want to model, along with the names of the members of your group. In this case, these 5 students are gonna model this boat, and all they did was just the right view, the top view, and the front view of the vehicle, and that's it. I don't need any dimensioning. I don't need a lot of detail, just a general idea. And the purpose of this is, if you are aiming too low, maybe a vehicle that is too simple, and then you will be lacking of parts to cover the requirements, or maybe it's too complex and you're aiming for a too complex geometries, too complex parts, and then I can just try to point you in the right directions. There are blueprints online, there are parts online, there are many inspiration strategies that I can share with you for this final project. So if you are unsure of what you should do, you have this week to decide. Otherwise, I will just assign something to you. And if you don't have a group yet, same thing. I will just assign your group, and then you will have to work with them. Again, I am posting the rules for the final project. Again, you will see all the details of these slides in the last week video tutorial and presentation. But again, here is the information if you need to check one thing or two. Remember that the groups are at least 4 members, maximum 6 members. If you want to work more or to be less, we can discuss and see how are the other groups behaving in this sense. So I'm flexible in that. Each member of the group should model at least 5 parts. If you do more, well, that's fine. I'm not gonna give you more credit for that. it will be just more work. So try to be smart in that sense. Um, all the parts should have at least 3 different features. So maybe a cylinder with just an extrusion will not be enough for completing one part. You should do a little bit more than just an extrusion. And I'm okay if you want to work with students from other sections as long as they are students in my sections. Because at the end I'm going to be grading you, and we don't want several TAs grading the same project. So it's just for that. So you can work either from with the students from sections 2 and section 3. Remember that for the final project there will be a final poster or presentation, and you will need to cover all of these items either in your poster or your presentation. And the grading rubric is going to be the following. I'm going to give 50% of the grade in the poster, so try to focus on that. Um, you will have to do a couple of blueprints. Technically, I'm gonna grade them, see if the dimensioning is correct, if the parts fit together, if you have all the required parts in your blueprint. So this will have to be a very professional work. And then a written report, an engineering written report. So try to use technical language, try to be very professional when doing this. And that will be the 100% of the grade. Finally, to deliver all the parts, all the blueprints and the assembly files, you will have to do a compressed folder, put everything together in a zip folder or RAR file. It's just the file extension of compressed folders. If you are unsure on how to do this, you can just check these quick YouTube videos on how to do this. It will take less than 2 minutes. Okay, now the tutorial for this week is gonna be this part. We are learning more and more how to do every week more complex geometries, how to render them, how to use not only extrusions and revolutions, but also how to add holes in a part. And not always those holes are gonna be circular. Sometimes you might have different shapes. Now I've selected this part because it puts together many of these things that we have learned so far in the course. Also, I'm gonna show the submission. The assignment for this week now. But I really recommend you to do the tutorial that I'm gonna show after showing the assignment. Because you will learn by doing this component how to do the assignment. Remember again that the assignments are due on Sundays midnight, and that you have to submit the SolidWorks part file and the PDF with screenshots of your progress. This will be the assignment. I'm providing you a section view here where you see this vertical line AA. Here you have that section view. It has some chamfers on the top of this curve and in the bottom part, as you see here, denoted by the discontinuous line. Or all of these hidden lines are just holes that you will see in different views. Again, here you have the isometric view to do this assignment. And remember, please to submit the list of the members of your group with the contact information and the draft. Okay, let's do the tutorial. I'm gonna open SolidWorks and create a new part file. And I'm gonna start by doing the front view of this part. As usual, you already know that I like to start by having these two lines for construction. And since this part is symmetric, I can only model one half of the part and then just use the mirror entities tool to complete the other half. So starting here from the origin, I'm gonna start doing some lines here, just the general shape. Okay, I'm gonna do that last part once again. So I know that you have the line selected and you should have this option line, but remember that when you move the mouse again to the original point, the icon is gonna change for a circle, and then I can do an arc. So this arc is gonna end in this center line, and I'm gonna add a couple of relations here. Now the first relation is that this center of the arc and this line are coincident, as you see there. Okay, and then I can just start adding dimensions. The first one is this 208 from this point to the other side. Then we have this angle here, 106 degrees, 106 degrees. So I'm gonna measure that angle here. Remember the way of doing angles is, sorry, I'm gonna show you again how to do that. You select the Smart Dimension tool, then one line of the angle, the second line of the angle, and then you place your angle somewhere. Remember that it's not the same to measure this angle than this angle. And the same goes for here or here. In this case, we need this angle. Okay. And then we have a height of 14 millimeters. And then a total height here of 68. Okay. Now I don't have information here in the section view. Remember that this dotted line here with these two A's at both sides, they mean that this is a section view, and that's what we have here in the bottom, a section view. In this section view, I don't have the information from the center to this vertical line. However, I know from watching this arc here, these two arcs here, that the radius of that arc is 54 when intercepting with this section view. So I can use this R54 to define that distance. Like that. And then I have this distance from here to here that is 56. So I can just select the center line, this other line and move my mouse here. 56. Like that. Then we have a vertical distance of 16. This vertical distance of this line is 16. And here I did a mistake. Actually, if you see, the center of that circle is not aligned with that line there. It's a little bit lower, so I will have to delete this arc, add that small line here, and then I can do that arc. Because this point of the center of the arc by default is going to be aligned with this beginning of the arc. So I just have to add the relation of this line at this point to be coincident. And then I can add this 4 millimeters in vertical distance from this step to the center of this arc. Now all I need to define here is the radius of this arc, which is 24. And that's it. I have everything is fully defined, as we see here in the bottom of my screen. Besides, all the lines are black now. So I can just mirror everything. I can just select everything and then unselect this line and this line. And then I can click here in mirror about this line. So everything is gonna do a copy from this center line. And that's our section view. Now you see that here we have a fillet, but I'm gonna add that at the end. I'm gonna leave it for the end, and you will see later why. Okay, now we can use this sketch to do a extrusion. In this case, I'm gonna select the mid plane here, mid plane, and that extrusion is gonna have a distance of 46 millimeters. Okay, now what I'm gonna do is I'm gonna go to the bottom and I'm gonna draw all of those holes that are going through the material, or at least partially in some cases. So let's go here to the bottom, to this surface, right click, and then we can select sketch. This option here that is called sketch. I press in my keyboard Ctrl 8 so I can have the XZ plane. And again, remember that I always start with this part. Okay. Now the first thing is that I'm gonna draw this square that it's a little bit into the material, only 2 millimeters. I'm gonna draw that square. Now the base distance of that square is 195. And then the vertical distance or the height is 35. Here we click 35. But that's not it. Now we can do also these two squares here, this one and this one. Or again, I can just do only one, and since the figure is symmetric, I can just copy everything. So I'm gonna do that instead. Gonna add another square somewhere here. And the distance from the center of that square to the other square is gonna be 78. So the second square is gonna be centered here. And in the center of that, well, we have first to define the sides, the length of the sides of that square, and here we have the size. This 2x28 means that there are two squares, the left and the right, with a side length equal to 28. So here I can define that 28, and the same for this one. Okay, and now I can do the circular hole that goes all the way through, that its diameter is 12, and there is another circle like that at the other side, which is this one. So we can do only one of that and then copy everything to the other side. This one is 12. We're almost done. Now we only have to do this shape. Which is here, and the straight slot. I'm gonna use the first option, which is the two centers first and then the radius. So I'm gonna just draw it here. Now we know that the distance between the centers of those two circles is 8. So we can come here and click between these two, only 8. And then the radius, or sorry, the diameter of those two arcs is 12. So we can just click this distance from here to here equal to 12. By default, these lines should be tangent, but they are not, so I'm just gonna add that relation here. Maybe that's not the case. Okay. It is not defined because I haven't defined the position in X of that slot. So we can define that position by taking the inner circle, and the distance from the other inner circle is going to be 154. So in that case, I can just select this center line, and click here 154. And now everything is fully defined, everything is black. So before doing anything, remember that we have to mirror these entities this square, this circle, and this slot to the other side. And that's it. We have all the holes that are going through the material, the entire cuts or some partial cuts, and we're gonna see how we can do those partial cuts. In the meantime, let's just click Exit Sketch, and we have that sketch in the base of our model. If I press Ctrl 7, you will see that it's in the base. Now, in selecting that sketch, I'm gonna go here to Extrude Cut. But here in Select Contours, I'm gonna select only this square, this portion of the square. Now that cut will go through only 2 millimeters. Here we change this 46 for 2. And it will be like that, just a partial cut. You see? Now I can deploy that cut that I just did, and I can select again the same sketch, that same sketch that we did before, and I can create a second cut. Now the second cut, I'm gonna use the squares that goes 12 millimeters. Sorry, only, yes, 12 millimeters from the base. So let's select those two squares and click here 12. Like that. And then I can select all the two slots and the circles to do an entire cut through the entire material. So again, I select the same sketch, extrude cut, I select the circles, the slots. Now in this case we're going to select through all. I will cut the entire material. Now we have almost everything done. Here we see that it has a chamfer here of 45 degrees and 1 millimeter, and the same goes for the other side. So we can do that chamfer. Remember that to do the chamfer, here in features, you go to fillet, and the second option is chamfer. We select the edge, and also this other edge. And here it's gonna be only 1 millimeter, and the angle is gonna be 45 degrees. 1 millimeter and 45 degrees. And we have that. Now we have to do this arc here that I spoke about at the beginning of the model, the one that has radius 54. And to do that one, I'm gonna select this plane here to create a new sketch. And then I'm gonna press Ctrl 8. And all I'm gonna do is I'm gonna create a circle from the origin of this plane, and that circle is gonna have radius equal 54. So I have the diameter 54 times 2, enter, 108. And I can exit this sketch. Now, in this case, I'm gonna extrude a cut. Again, I'm gonna switch the direction. I'm gonna select through all. And in this case, I'm gonna select or check this option that says flip side to cut. And then we see that we have this small arrow here. Now, this arrow means that if I want to cut whatever is inside, it will remove the material that is inside that circle or that cylinder. Or if I want to remove whatever is outside and only preserve what is inside. It's like a Boolean operation. So basically here we're doing a Boolean Union operation between the cylinder and everything else. We can actually see how it will be, the final product. Check if I change the direction of the arrow. It will not be able to do that cut. So remember to have this arrow pointing outwards of that cylinder. And then we have that arc there, that curved surface there. We have one last thing to do here, and is these fillets here on the right and the left. And that's why I wanted to have this at the end, because those two fillets are going to be for the curved surface, not the straight line that we had before. So here under features, there is this button that is called fillet, and I can just select this. Sorry, I'm gonna select the first option, that is constant size fillet. I select this curve and this curve, and both has radius equal 8. So click OK, and our model is done. If you want to verify the hidden lines that we have here in the top view, we can do Ctrl 5, and there we have those hidden lines. They should match whatever we have here. And also, if I want to do maybe a section, I can select the front plane and then activate the section here. And then we see that everything that is blue should be the same that has these parallel lines in the material, and that represents what the portion of the section that has material. So it's the same here. Maybe there is, yep. And there will be that section view. I can deactivate it. And that's it. That completes this tutorial. I should just save this. SolidWorks is reminding me that I haven't saved anything in a while. Try to do this tutorial, and then you can continue with the assignment. If you have any questions, any doubt on how to do any part of this assignment, just let me know. Send me an email or communicate with me in the chat, and we can arrange a meeting in WebEx so I can try to help you. Thank you, everyone. Have a good weekend, and see you next week. Bye-bye.